Good day everyone. In continuation of our previous class on laws of indices, in this class we shall be looking at illustrative examples of how to apply laws of indices. At the end of the lesson, learners should be able to evaluate numerical expression using laws of indices. Let's look at some examples. We have the first 5 raised to the power 5 divided by 5 raised to the power 2, followed by the second example, which is k raised to the power 3 times k raised to the power 5 times k raised to the power minus 2. The third example is 81 raised to the power minus 3 over 4 times 9 raised to the power 1 over 2 times 27 raised to the power 0. And now the fourth example is open bracket 7m raised to the power minus 3 close the bracket raised to the power 2 times open the bracket 21n raised to the power minus 2 close the bracket raised to the power minus 1. And the last question there will be DIY, do it yourself, which you'll be able to apply the knowledge you have acquired in the first, second, third and the fourth example to be able to tackle the simplification, the evaluation of the fifth questions, which I expect you viewers to drop your answer at the comment section of this video. So let's move. Before we move further, as part of the law of indices, anything raised to the power 0 is 1 except 0. So if 0 raised to the power 0 is not 1, this is on the vine, but any other value raised to the power 0, be it 1000 raised to the power 0, 100 raised to the power 0, p raised to the power 0, anything except 0 that is raised to the power of 0 is 1. So let's move straight to the first example, which is 5 raised to the power 5 divided by 5 raised to the power 2. By the law of indices, when you have the two having the same base, but the operation between them is a division sign, and you can see the power, they have different values. So what you need to do is you pick one of the identical base and you subtract the power. That's 5 minus 2, which is 5 raised to the power minus 3, and you can break this down to be 5 multiplied in 3 places, 5 times 5 times 5, which gives 125. So in the second example, we have k raised to the power 3 times k raised to the power 5 times k raised to the power minus 2. Using the law of indices as well, since we have identical base k, so we take k and the operation between these are multiplication. So you have the power, that's why we have 3 plus 5 plus. Be mindful of this point. This is plus open bracket minus 2. So in a case whereby this is division sign, don't forget this will be minus, and this minus is going to have it what is here. So in this case we have in times, so that is why we have plus. So in that case we have k raised to the power 3 plus 5 minus times plus times minus will give us minus. We have 3 plus 5 minus 2, which gives 6. So the third example, which is 81 raised to the power minus 3 over 4. So at this point you can observe that we need to apply the law whereby this minus returns to 1 along the division sign. 81 raised to the power 3 over 4 multiplied by, we do the same thing for this. This is going to be the fifth root of 2 for the 3, everything close bracket raised to the power 1, and anything raised to the power 0, like I've said in the previous slide, that anything raised to the power 0 is 1. That's why this one is 1. So when you try to break it down further, this will be the fourth root of 81 raised to the power 3 times the fifth root of 2 for the 3 raised to the power 1 times 1. And here this is telling you that you must try to express 81 as something raised to the power 4, and this is going to give you 3 raised to the power of 4, and this power of 4 is going to cut out the fourth root and you are left with 3, and this 3 also will be put here as the power. The same thing goes with this. we are going to express 243 as something raised to the power of 5 because of the fifth root here. So this is going to be 3 raised to the power of 5, and by that the fifth root is going to cross out the power 5, and we are left with 3 raised to the power of 1. So in that case, you can now have this in this form. 1 divided by 3 raised to the power 3 can also be written as 3 raised to the power minus 3, plus, because of this operation, the power 1, plus is the 1 there can be written as 3 raised to the power 0. That's why we have 0, and by the time you can have the next thing there. So we move on to the next example, and this is quite different from the previous example 1, 2, 3. You can see that this operation, the square, is going to act on each of the variables, each of the elements in this bracket. That's why we have 7 raised to the power 2, m raised to the power minus 3 close bracket 2 times the same thing at this point. This minus 1 will act on 21 separate, and with this minus 1 being the power, we also act on n raised to the power minus 2. And by doing that, you can see that 7 raised to the power 2 will give 749, and m raised to the power minus 3 close bracket square will give us m raised to the power minus 6 multiplied by 21 raised to the power minus 1. This gives minus 2 times minus 1 will give us plus 2. And by the time you try to multiply 49 by 1 over 21, you are left with 7 over 3. And this comes together. So in this case, you can observe this is m, this is n, so they are not the same. But at the same time, because there is a multiplication sign, we can make them come together, but we can't apply the law stated earlier, so we can't do anything to the power, so they will remain the same. So that's why we have it in that form. So you can see, once again, take note, in the case whereby you don't have the same base, and you are having something in brackets raised to power, so the power is going to act on this. So you take note of that whenever you are trying to solve a problem. So we come to the end of this video, and before we go, try as much as possible to do this exercise on your own and drop your answer at the comment section of this video. And doing that, you'll be able to get used to how you can apply lot of indices to evaluate a numerical expression or algebraic expression. Thanks for watching. Press like, share and subscribe for the next video. Bye for now.